I may have given this to you already. All right. Now, I can share this with you now. I can also give it to you before class on Wednesday.
Does that mean the probability increases that they'll do better?
Say that again?
If they had the program now, if you give it to them once before, so now we increase the probability.
Probably, yes. I'm sure somebody erased it here and there. So the first thing you have to do is you have to build the distribution in your calculator. So this is why I always like having you guys write down the t-table, at least in the beginning. So let's build my flock again. X is the number of girls in my flock. What's the smallest number of girls I have in my flock?
0.
0. What's the largest?
4.
4. Hit enter. At this point, it has put 0 through 4 in L1, and it's waiting for you to fill in L2. Now, what should I fill L2 by? Binomial. And then it asks, what probability are you using for that event that you put in L1? So L1 was a number of girls, right? What's the probability of girls? 0.9.
What was the program again?
We're just doing that again, but in the TI.
Okay.
Okay, ready? Now it says done. You're like, okay, great, it's done. But wait, I'm low 5, friends. I'm low 5. When you go back to your L1, L2, look what's in there. It just built that for you. It saves you the binomial coefficients. It saves you having to keep track of the events here and there, here and there. Is that fair? So, where this comes in handy is, suppose you needed to analyze, say, a flock of 32 birds. Well, that's where it really shines, is that you go 0 to 32. It takes a little bit longer. Binomial, it's still 0.9, right? Go ahead, it's going to take a little while for it to fill. It's crunching all those numbers in its brain. There it is. And now when you go back in there, all the probabilities are listed for you. Now look, those are very small. That's 0.00000000009. Because you should not be getting 13 girls and 19. You shouldn't be getting 13 girls and 19 boys if 90% should be girls. You should not be getting this few girls, should you? You should be getting more, yes? You should be getting more. They should be sliding up here. Ah, here we go. 2.4%, 6%, 11%. What's the highest probability? 23%. That corresponds to 29 girls. On average, that's what you should be getting, right? If you actually calculate, go ahead.
Why is it less than 30?
Yeah, why is that?
Why is what less than 30? Because the 0.9 probability, remember? 0.9 probability. 90% of the 32 rounds closer to the 29 than the 30.
Yeah.
It's round it closer. The average is going to give you to a tenth or a hundredth of a decimal place, correct? Oh, that was me. Run the average. How many girls should you expect on average? 0.9 times 32.
Okay.
Rounds to 29, not 30.
29.
The average is closer to 29 than 30.
Oh.
So the biggest probability points to the average as well. Fair?
Fair.
Fair-ish. We'll come back to that on Wednesday. We're getting ahead of ourselves a little bit. If you want this, give me 5 seconds up here. I can link it into your calculator. I don't know how else to give it to you other than that. Oh, good for you, Corey. Yes, you
push that?
about this. Yes. Excellent.
Is this recording still?
Yes.
Or not lose my money.